In this module, we're going to get into some security and message hygiene topics. The first is Transport Layer Security, or TLS, which is all about protecting email in transit. We'll also look at the Sender Policy Framework, or SPF, which is intended to reduce spam and spoofing of your domains. After that, we'll look at the built-in anti-spam features of Exchange 2016. SMTP is not in itself a secure protocol. SMTP, when it was originally conceived, had no considerations for protecting the communication between two hosts from being intercepted and read. Everything is just in the clear. If you were to telnet to an Exchange server and issue SMTP commands to send data, all of those commands and data, including any authentication credentials you happen to use, would be sent in the clear over the network. Now that is obviously not ideal, but it's also not a huge problem, or at least not a reason to panic. Yes, security is super important, and we should be using encryption where possible, but most of your clients are not using unencrypted SMTP connections to send email through your Exchange servers. Outlook clients are using secure RPC or MAPI connections over HTTPS. Outlook on the web and mobile clients are also using HTTPS. Devices and applications on your network that are doing anonymous relay are doing so without sending credentials, although the data itself that they're sending is unencrypted, so there's some risk there. POP and IMAP clients are hopefully making secure POP and IMAP connections, but might be making insecure SMTP connections, so there's also some potential risk there as well. Fortunately, the SMTP protocol was improved and now it supports encrypted connections. The start TLS verb was added to SMTP to make this possible. TLS is Transport Layer Security, the successor to SSL, although in general conversation people usually just say SSL anyway when they mean TLS. There are three ways that Exchange can use TLS. The first is opportunistic. With opportunistic TLS, Exchange will accept start TLS requests from other hosts. It will send start TLS to other hosts, and if a TLS session can't be established, Exchange is happy to just fall back to an insecure connection. Opportunistic TLS, if it's successful, can provide confidentiality for the email in transit, but not authentication about who is sending or receiving that email. With forced TLS, Exchange requires TLS for inbound or outbound SMTP, and if TLS fails, then the connection fails. Again, with forced TLS, you get confidentiality of your connection and the data that is transmitted across that connection, but not authentication about the other host that Exchange is connecting to. Now, both opportunistic and forced TLS will actually work with untrusted certificates, such as self-signed certificates. So the communications are still encrypted, but there is some risk that even though the connection is being encrypted, in doing so with self-signed certificates, you really just do not get any validation about who you're connecting to or who is connecting to you. With mutual TLS, TLS is required for inbound and outbound SMTP, fails if the TLS session can't be established, so it will not fall back to an insecure connection. And one of the reasons that it might fail is if the certificate can't be validated. So now with mutual TLS, you get confidentiality for the data transmitted over that connection, and you also get authentication as well. In Exchange terminology, when you have Exchange servers at both ends of mutual TLS, this is referred to as domain secure or domain security. Both terms are used and they basically mean the same thing. To be honest, this is incredibly rare to find in the real world. It's the kind of thing that is helpful to be aware of, and you can go and look it up and refresh your memory if you ever need to actually deploy it in a production environment. But this course is as much about real-world skills as it is about preparing for an exam, so you might also see some exam questions about domain secure, so let's take a quick look at it. Domain security is possible when two edge transport servers for different organizations perform mutual TLS. This obviously requires valid certificates because the certificate itself is checked for validity. For example, that it has come from a trusted CA, matches the domain name of the email sender, hasn't expired or been revoked. If domain security is configured but fails mutual TLS, mailflow will stop working between those domains. If domain security is successful, Outlook users will see a domain secured icon on the messages in Outlook. So there's a user education part to this as well. There's not much point deploying domain security to assure secure mail flow between two organizations if users don't know to look for that assurance on the messages themselves. Finally, domain security doesn't work if there's non-exchange servers involved in the mail flow between two orgs. So that pretty much rules out the majority of organizations, since most people do use a third-party spam filtering product or spam filtering service in the real world. To configure domain security, we use the set transport config on one of the exchange servers in the organization and specify the domain names for which domain security should be used for receiving and for sending. So they are separate lists. You can have domain security in just one direction or in both directions with a particular partner organization. You then need to configure a partner send connector using the new send connector commandlet and use the partner switch to specify partner as the type of send connector. So that will automatically configure the send connector with the correct TLS settings and domain security settings. And then all you need to do is give it a name, specify the address spaces that send connector should be used for, a fully qualified domain name, and set the source transport servers, which must be edge transport servers. The DNS routing enabled set to true means that MX records will be used for this send connector. The other alternative is to specify a smart host. For domains that you want to receive email from with domain security, the new receive connector commandlet is used to create an inbound receive connector of the type partner and specify the remote IP ranges of the partner's email servers. So to summarize those requirements for domain secure or domain security, the set transport config must contain the domain names in the send or receive list for the partner organization. You'll need send and receive connectors for partner usage, and a valid certificate must be installed and enabled for SMTP on the edge transport server. If you just want TLS but not domain security, there's no configuration required at all for opportunistic TLS, and if you're going to try and force TLS, you need to simply set the required TLS attribute on any send or receive connectors involved in that secure mail flow to a value of true. In this video, we'll look at the Sender Policy Framework, or SPF. The goal of SPF is to prevent or reduce the spoofing of your domain names by spammers and other malicious actors. SPF is implemented as a DNS record. You might already be familiar with the idea of servers doing an SPF lookup for a domain. Well, they perform that lookup in DNS by looking for the text record that contains the SPF information. SPF records are not actually mandatory, but they are recommended these days because more and more mail hosts are rejecting email from domains that don't have an SPF record. So here's how SPF basically works. Your Exchange server is going to make a connection to a third-party email server. It's going to announce itself as perhaps mail.globomantics.biz and say it's got an email from adam.wally@globomantics.biz. The third-party email server is going to look up the SPF record for your domain in DNS, and when it has found that SPF record, it's going to analyze it and say, is that particular IP address that is connecting to me allowed to send email for the globomantics.biz domain? The answer to that question will depend on how the SPF record has been constructed. The SPF record is simply a text record in DNS with a certain syntax. The syntax is made up of two parts: mechanisms and qualifiers. The mechanisms include all, which matches any host. So this is placed at the end of the record as a catch-all to say what should be done for any hosts that aren't otherwise defined in the SPF record. IP4 matches a single IPv4 address or network range. IP6 does the same for IPv6 addresses. A will match a host name or domain name. So the receiving server will look up the A record of the domain in DNS, and if it resolves to the IP address that is making the inbound SMTP connection, then that's a match. MX matches against the MX records for the domain. This is a useful mechanism to use when outbound mail for your organization is handled by the same servers that MX records resolve to for inbound mail. It's a nice simple way to construct your SPF record. PTR uses reverse DNS to match the sending server's IP address to the host names that it resolves to. This is not generally recommended because it causes a high load on DNS and it can be quite slow. Exists simply checks that the domain name the email is trying to send from actually exists at all. Include lets you defer the SPF lookup to the SPF record for another domain. This one is usually used when outbound email is routed through a cloud service such as Exchange Online Protection. You're basically saying as long as their SPF record says it's okay, then it's okay by me. So there's lots of options there. SPF records can contain more than one mechanism, and you then need to combine the mechanisms with qualifiers. The qualifiers include the plus symbol for pass, and this is the default qualifier if none is provided. Minus for fail, so email from unauthorized hosts should be rejected. Tilde character is for soft fail. Email can be accepted but should be treated as possible spam. Then a question mark is used for neutral, basically to say accept the email whether SPF lookup is successful or unsuccessful. Now all that starts to make a little bit more sense when you look at some examples. So here's a simple example. This SPF record basically says accept email from MX records for the domain. Accept email from the IP address that the domain resolves to, so that's likely to be a web server that might be sending out email notifications as well, and then soft fail anything else. As another example, this record will say accept email from that particular IP address. Again, that could be a web server that sends email notifications or an external monitoring server, or perhaps a third-party hosted survey service that is sending out emails using your domain name. It also includes the SPF record from the Exchange Online Protection service. So whatever IP addresses and host names Exchange Online Protection says are okay, will be okay for us as well. And then it will hard fail all others. Now just keep in mind that SPF records are only a suggestion. Receiving servers can ignore them, or they can override the actions with their own decisions. But that's no reason not to implement SPF records for your domain. So let's jump into the Globomantics environment and configure an SPF record for the globomantics.biz domain. First, we'll just confirm that there isn't currently an SPF record for this domain. So this is mxtoolbox.com, and amongst their tools is an SPF record check. And the result of that check right now is that there is no records found. So that's the problem that we need to solve. Now, crafting your SPF records by hand is one approach, but of course it assumes that you fully understand all the mechanisms and qualifiers and you have some experience. But there are useful tools such as spfwizard.net that can walk you through the process and generate the SPF record for you. So we'll start by entering the domain name globomantics.biz, and then we just answer a few questions. Should we allow the servers listed as MX records to send email for this domain? Well, yes, that does make sense for Globomantics because all of the inbound and outbound email is handled by the same servers. Should we allow the current IP address of the domain to send email for this domain? So that would typically resolve to the website for globomantics.biz. In this particular case, no, we do not need to include that IP address because the Globomantics website does not send any email. Should we allow any host name ending in globomantics.biz to send email for this domain? No, we don't want some blanket domain-wide access to be able to send email in this case. Only the servers that correspond with MX records should be allowed to send. Is there any other server host name or any other domains that send email for this domain? No, not at present. But later on, if Globomantics was to engage a third-party provider for something such as payroll services or running marketing surveys, they may need to revisit this configuration. The final question is how strict should that SPF record be complied with? We can say fail, soft fail, or neutral. Let's say soft fail because perhaps we're a little bit unsure about whether there's any stray services or servers out there that may still be sending mail, and we don't want to completely hard fail everything at this point. So we get this text record here. We need the portion of the record that is within quotes. And that needs to be added to the globomantics.biz domain. The type of record is a text record. We'll just paste it in there. How you do this will depend on how your DNS is managed. Different DNS providers have different consoles. Some allow you to create multiple text records. Some require you to put all text record values into a single record. But either way, in this case, the text record has been created with that SPF information. A DNS propagation in Amazon Route 53 is pretty fast. So let's go back to MX Toolbox and we'll do that SPF test one more time. And this time an SPF record has been found. Record has been found, the record is valid. There are no multiple records, there are no deprecated records. All green ticks there, everything looks good. So what does that look like to other servers on the internet? Let's send one more email to the Gmail address. And after that message arrives, we'll just go in and grab the headers from that message and put them in the MX Toolbox header analyzer. And just skipping past, what we're interested in seeing here is the SPF result. And we can see that SPF has passed in this case. The public IP address of the Edge Transport server is a permitted sender for the globomantics.biz domain. So with that SPF record implemented correctly, in theory what should now happen is any mail systems such as Gmail that are checking SPF records should no longer allow spammers to spoof the globomantics.biz domain. Now that Globomantics has an SPF record that should help prevent spammers from spoofing their own domain, it's time to look at protecting the Globomantics users from spam as well. Now obviously it's a good idea these days to protect an email server from spam because some spam is annoying and some is downright malicious. In the real world, most customers will use a third-party email security service or product, one that is either hosted in the cloud or installed on premises as a virtual appliance or directly on the Exchange server. For customers who don't have a third-party solution available, Exchange offers some built-in capabilities. The Edge Transport and Mailbox server roles have different message hygiene capabilities, and in fact, the Mailbox server role has different capabilities out of the box than if you install additional agents. On an Edge Transport server, the agents are the connection filtering agent, content filter, sender ID, sender filter, recipient filter, protocol analysis, and attachment filter. For a Mailbox server, by default, the only agent is the malware agent. But if you go ahead and install the anti-spam agents by changing to the EX scripts path and running the install anti-spam agents script, the additional agents will be available after you restart the transport service, and the Mailbox server will then have the content filter, sender ID, sender filter, recipient filter, and protocol analysis. And of course, it will also have the malware agents as well. Since the Edge Transport server role has more agents than the Mailbox server, that's what we'll use for the Globomantics examples, and then take a look at the malware filtering on Mailbox servers afterwards. Connection filtering is the first line of defense because it is also one of the most effective. Connection filtering is based on the source IP address of any SMTP connection. If you can block all the IP addresses that are known spammers or that are likely spammers because they're coming from a bad neighborhood, such as an ISP's customer IP range where lots of malware is trying to send out spam, then you can block most spam before it even hits your servers. Connection filtering can use block or allow list providers that maintain a database that you can query to determine whether an IP address should be allowed to connect or not. The add IP block list provider commandlet is available for adding a block list provider. An example of one is Spamhaus that operate a pretty good block list that you can subscribe to. Just make sure you check the terms and conditions of any provider that you plan to use, or you can add your own manual entries for IP addresses and ranges that you want to block or allow by using the add IP block list entry commandlet. But you'll generally find that the list providers are much more efficient and effective. So let's quickly go into the Globomantics environment and add an IP block list provider to the Edge Transport server. So on the Edge Transport server in the Exchange Management Shell, we can run the add IP block list provider commandlet, specify the name that you want to assign to this block list provider. You can use any name you like, but of course it makes sense to use the real name of the block list provider. The provider will give you a lookup domain, which is a DNS name that your server will query, and a rejection response, such as IP address is listed by Spamhaus. Now it's useful to put a rejection response in there, because if a legitimate sender is being rejected by your server, that response will be logged in their server logs, and that's going to help them with their troubleshooting. They won't see the issue as being your server blocking them. Hopefully they'll see the issue as their IP address being listed by the Spamhaus block list. And then they can go to Spamhaus and they can try and be delisted there. Now you can add multiple entries if there are other block list providers you'd like to use as well. Most organizations only need one or two. Next up is content filtering. Content filtering makes filtering decisions based on the content of email messages. The content filtering agent will analyze the contents and apply a spam confidence level, or an SCL score, which is basically an indication of whether the content is spammy or not. And based on that SCL, you can choose to reject or delete or quarantine so that the most likely spam doesn't even reach your users, but email that is simply spam-like, that may be grey mail, it may not be actual spam, it can be quarantined instead or sent to the user's junk mail folder. You can also add your own phrases and keywords to influence how content filtering scores a particular message. So again, we'll go into the Globomantics environment and look at configuring content filtering. In the Exchange Management Shell, the Add Content Filter Phrase commandlet can be used to add any phrase that you like into the content filtering engine, and then you can choose what influence that word should have. So in this case, the phrase foobar should have an influence of bad word. In other words, the presence of the word foobar should indicate that the email is more likely to be spam. And in most organizations, there are email addresses where the thought of false positives or email that isn't spam being accidentally rejected as spam to particular addresses is not ideal. So public-facing contact mailboxes or help desk mailboxes or sales teams may prefer to receive more spam rather than run the risk that legitimate email will be blocked. So we can set the content filter config to bypass particular recipients. So in this case, we're bypassing helpdesk at globomantics.biz from content filtering. That doesn't necessarily bypass it from other anti-spam measures. So connection filtering, for example, would still block a spammer's IP address, but the content filtering engine won't pick up any spam for that particular recipient. Next, let's look at sender ID. Sender ID uses the sender policy framework that we've already looked at in this module. Sender ID is enabled, so SPF lookups are being performed by the server, but the default action is to stamp status. In other words, Exchange will not reject email even if it fails an SPF lookup. Instead, it will just stamp the status that the SPF lookup failed in the message headers and then continue to allow it through. The message may be blocked by one of the other anti-spam agents, but sender ID is not going to make that decision. You can, of course, configure the sender ID policy to reject any mail that fails SPF lookup as well. If you have particular senders on the internet that you're having trouble with, you can configure bypass rules for those senders or for internal recipients, so that SPF is not considered for those particular senders and recipients. And of course, sender ID is only effective if the sender's domain actually has an SPF record. If they don't have an SPF record, there's nothing for sender ID to look up, and therefore it can't make any decisions at all. So we'll go back to the Globomantics Edge Transport server and configure sender ID to reject email messages. In the Exchange Management Shell, run the set sender ID config commandlet and set the spoofed domain action to reject. So by configuring sender ID in that way on the Edge Transport server, we're telling the Edge Transport server to use SPF to validate that incoming email complies with the SPF records for senders' domain names. Sender filtering is quite a simple concept. Sender filtering simply makes filtering decisions based on domains or sender email addresses that you choose to block. You can reject, or you can simply stamp a status for senders that you don't like. When you're configuring sender filtering, you have a couple of options. You can set sender filter config and add to your blocked senders list either a full email address or just a domain name, or you can also block domains and subdomains, and this is a very powerful option because it means that you can block entire top-level domains. So if you're receiving nothing but spam from a particular top-level domain or a country domain, you can just block that entire domain using the sender filter config. Recipient filtering is also fairly straightforward. Recipient filtering will make filtering decisions based on the recipient of an email message. So it can check for things such as non-existent recipients, restricted distribution groups, and mailboxes that you consider to be internal-only mailboxes, and you've configured to only accept email from internal senders. Recipient filtering achieves all this by synchronizing recipient data to the Edge Transport servers as part of the Edge Sync process so that they can make those recipient filtering decisions. For accepted domains that are configured as internal or external relay domains, the address book enabled property needs to be considered in light of recipient filtering. Address book enabled should only be set to true for authoritative domains. It must be set to false for internal relay domains, and it must be set to false for external relay domains. The reason for that is because recipients for internal or external relay domains that are not part of the local exchange organization will not be able to synchronize any recipient data as part of the Edge Sync process. In other words, the Edge Transport server won't know about them, so it will treat them as non-existent recipients, when in actual fact they exist in the other organization that is sharing that namespace. The address book enabled property is set at the time the accepted domain is created. If you create an accepted domain as authoritative, address book enable will be set to true, which means if you later change an authoritative domain to an internal or external relay domain, you should remember to set the address book enabled property to false to prevent recipient filtering from making the wrong decisions. So if this recipient filtering feature is checking for recipients that exist and non-existent recipients, could spammers potentially use that recipient validation process to find legitimate email addresses in your organization? This is called a directory harvest attack, where spammers will use the response, whether a recipient is valid or not, to work out whether email addresses that they may have in their database are real and should be targeted with more spam. To address that risk, Exchange will tar pit any high volumes or suspicious behavior by an interval of 5 seconds. So if a spammer is hammering your Edge Transport server with lots of these connections that are designed to harvest your directory, Exchange will recognize that and it will slow them down by waiting 5 seconds for each response. You can configure the tar pit interval on your receive connectors by using the set receive connector commandlet. Generally, you can leave it at 5 seconds. That's a good value, but if you're getting completely hammered by these types of attacks, maybe you can increase it as well. And just also keep in mind that connection filtering will also help prevent those SMTP connection attempts. So we'll go into the Edge Transport server again and look at configuring recipient filtering. By running the set recipient filter config commandlet, we can enable the block list on the recipient filtering agent. When that agent has been enabled, we can specify particular recipients within the organization as blocked recipients. So if you have particular email addresses that are internal use only, add them to the recipient filtering block list, and that will prevent any external senders from being able to send to them. The protocol analysis agent is quite an interesting one. This is the agent that works out the sender reputation level. Sender reputation is made up of several factors that are analyzed by the protocol analysis agent. The hello or elo domain is checked because spammers will often forge multiple different names when sending from the same IP address. So the protocol analysis agent is able to pick up on suspicious behavior from the same IP address. The hello and elo domain name is also checked to see whether it matches the IP address that the SMTP connection is coming from. Since spammers often forge the hello name This lookup should fail for spammers and it should pass for legitimate senders, assuming that you've put a reverse DNS record in place for outbound mail flow. In other words, if your server is announcing itself as mail.globomantics.biz, then the public IP address that it is NATing to for outbound connections should have a reverse DNS record that also resolves to mail.globomantics.biz. The content filtering agent is able to apply a spam confidence level, or SCL, to messages, and the protocol analysis agent takes these into account. A sender that frequently sends mail that scores very highly will be considered to have a worse reputation than a sender that frequently sends clean email. And finally, there is the open proxy test. Exchange will send an SMTP request to the other server to try and relay back to itself. If it is successful, then the server is acting like an open relay, which is a bad thing, obviously, since spammers will likely be abusing that misconfigured server to relay spam. Therefore, emails from that server are more likely to be spam. All of that is taken into account, and if the score is above the threshold for poor reputation, the protocol analysis agent requests the sender filtering agent to add the sender to the block list for a period of time, which is 24 hours by default. It's then up to the sender filtering agent whether to reject or stamp the emails depending on how you've configured that sender filtering agent. Now let's talk about attachment filtering. Attachment filtering is one of the agents that is available only on Edge Transport servers. You can't install the attachment filtering agent on any mailbox servers. The attachment filtering agent is pre-configured with a list of file types to filter, and it's the typical things such as executables and scripts. As the administrator, you have the choice to reject emails that contain those attachments, or you can strip the attachment from the email and the Edge Transport server will replace it with a text file explaining that the attachment has been removed. You can use the get attachment filter list config commandlet to take a look at the existing configuration, and if you expand the attachment names property, you'll see a full list of the file types that the attachment filtering agent will take action on by default. If you decide that you don't want to strip the emails but you'd rather reject them instead, use the set attachment filter list config commandlet and set the action to reject instead. And of course, if you have a file type that you need to add to the attachment filter configuration, use the add attachment filter entry commandlet and add the file extension that you want to filter. As a final point about anti-spam features, let's look at safe list aggregation. In Outlook and Outlook on the web, your users are able to manage a personal block and allow list for sender email addresses and domains. That is their safe list. In an enterprise environment, you wouldn't want to block an email that is being sent to someone who has marked that sender as safe, nor would you want to bother delivering an email to a mailbox if that person has already added that sender to their block list. So Exchange is able to aggregate that information to be used during anti-spam filtering. You might like to know that the server only stores a one-way hash of the data, which, apart from being more space efficient in terms of server storage, prevents the data from being used by an attacker if they were to somehow get a hold of it by compromising the server. That way an attacker does not learn a whole bunch of email addresses that users consider safe and could then begin a phishing or spam campaign using those safe listed email addresses. The safe list aggregation data is used by the content filtering agent to avoid unnecessary processing of emails from safe senders. The data is also used by the sender filtering agent to block any senders who have been blocked by mailbox users. Safe list aggregation is enabled by default, and you don't really need to do anything to keep it working, but you can manually run update safe list if you think that the Edge Transport server has not got the latest safe list information from the mailbox users. Finally, let's take a look at malware filtering. The malware filtering agent only exists on mailbox servers, and during setup there's a question as to whether you want it enabled or disabled. It's enabled by default, and if you chose during setup to disable it and you want to re-enable it later, you use the set malware filter server commandlet for that task. Malware filtering occurs at the transport layer, not the database layer. Once email has made it into the database, there's no longer any malware filtering occurring on those email items. And despite the presence of the malware filtering agent, you should still consider running file-level antivirus products on your Exchange servers to protect the operating system and the file system from any malware that may accidentally get onto the server. When you do that, you just need to be sure that you follow the recommendations that Microsoft publishes on TechNet about excluding specific folders and file types and processes from that file-level antivirus so that there's no file locks or conflicts with how Exchange works. So let's wrap up this module in which we learned about how Transport Layer Security or TLS protects mail in transit, how the Sender Policy Framework or SPF can reduce spoofing of your domains, and how the Exchange 2016 anti-spam and anti-malware features can help prevent spam and viruses. They're not commonly used in the real world, but they are available to you if you don't have third-party products or services available to use instead, and you at least need to know about them in case you get any questions on the certification exam. Coming up in the next module, we're going to look at monitoring and troubleshooting.